In the previous class, we have talked about group of symmetries of an equilateral triangle, that is nothing but D3, or it is also called as group of symmetries of a regular polygon having 3 sides. And while discussing that example, we have introduced some notations to the elements of D3: E, sigma, sigma square, tau, sigma square tau, where sigma is a permutation of length 3 and tau is somewhat like this. The important thing to note here is that 1 is mapping to 1 in tau. Now we are going to generalize this notation. So in general, Dn is actually collection of sigma and tau. As you can see, the elements of D3 are simply the combinations of sigma and tau. So the elements of Dn is actually collection of sigma and tau such that sigma raised to n is equal to E, which is equal to tau square. So in D3 you can see that sigma cube is absent because sigma cube is E. Tau square is also absent. The reason is tau square is also E. Further, one more condition, sigma raised to n minus 1 tau should be equal to tau sigma, where sigma is cycle of length n, somewhat like this, as you can compare, and tau is nothing but, again 1 is mapping to 1 here, and the images of rest of the elements you have to write in reverse order. I mean, this is 2, 3 up to n, then you start with n minus 1 and go up to 2 here. Yes. So this is nothing but the generalized notation for Dn. Now let us write down D4 with the help of this generalized notation. So it will be collection of sigma tau such that value of n is 4, right? So sigma raised to 4 will be E, which will be further equal to tau square. This will be sigma cube tau, which is equal to tau sigma. Now the idea here is you start with E and go on taking the powers of sigma. So first of all sigma, then sigma square, then sigma cube, and continue in this way: sigma, sigma square, sigma cube. But if I write sigma raised to 4, you will get E, right? So at this point you will stop. Now in order to write rest of the elements, we can simply multiply these 4 elements by 2. Either you can multiply it from the left hand side or from the right hand side, that is your choice. So in this case I will multiply from, let us say right hand side. So it will be tau, sigma square tau, and sigma cube tau. So this is actually nothing but our D4. Now if you note, the number of elements in D4 are 8. So in general, remember, order of Dn will be what? Order of D3 we got it to be 6, order of D4 we got it to be 8. So in general, order of Dn is actually 2n.